It is 019 on 25th of July 1943, and in a concrete bunker near the North Sea coast, 3 radio measurement engineers sit before a bank of glowing tubes, watching something that should not be possible. Their Würzburg-Riese dish, slaved to the Egon guidance apparatus, is meant to hold a single steady blip. One bomber, tracked to within a few hundred meters, ready to be handed to a night fighter or a flak battery. Instead, the screen is filling with light. Dozens of echoes appear, then hundreds, spreading across the display like frost creeping over glass. One engineer leans forward and adjusts the antenna bearing, certain he has mistuned the elevation. He checks it again. The angle is correct. The equipment is not broken. It is being lied to thousands of times a second, and none of the 3 men yet understand why. Beyond the bunker's narrow observation slit, the sky over Heligoland is empty and dark, the stars visible, no engine noise audible yet on the sound locators. But the screen insists otherwise. A swarm, a blizzard, an impossible density of aircraft. 90 kilometers to the southeast, air raid sirens are about to wake a city of 1.5 million people. The engineers do not know it yet, but the elaborate radar chain they have spent 2 years perfecting. The Kammhuber line, the Würzburg sets, the Freya early warning stations, the Egon triangulation system built to guide bombers and fighters alike, has just been rendered almost useless by a few thousand strips of blackened paper and tinfoil, cut to a length of 30 centimeters and dropped by hand from the bomb bays of Royal Air Force Lancasters. To understand why 3 trained specialists could be defeated by paper, one has to go back to 1940, when Colonel Joseph Kammhuber was given the task of building Germany's night air defenses almost from nothing. His solution became known as the Kammhuber line, a belt of radar-controlled boxes, each roughly 30 kilometers across, running from Denmark down through the Low Countries. Inside each box, a Freya radar gave early warning out to about 100 kilometers, while a pair of Würzburg dishes, accurate to within meters, tracked 1 incoming bomber and 1 German night fighter simultaneously. A controller on the ground working from a plotting table read off both positions by radio and talked the fighter onto its target, a method the crews nicknamed Himmelbett, the 4-poster bed. Later refinements added the Egon system, short for Erstling-Gemse Offensive Navigation, which used a modified Freya to trigger an aircraft's identification transponder out to ranges of 250 kilometers and fix its position by triangulation, borrowing a principle similar to the RAF's own oboe blind bombing system. By the summer of 1943, more than 30 of these boxes studded the coast, backed by roughly 55,000 flak guns and 8,000 searchlights defending the Reich, and Bomber Command's loss rate on major raids had climbed uncomfortably close to 5% a trip, a rate no crew could survive across a standard 30-operation tour. Losses over the Ruhr Valley alone during the preceding 5 months had run into the hundreds of aircraft, each carrying a crew of 7, and Air Ministry planners in London were openly discussing whether the bomber offensive could continue at its existing tempo without a technical answer to the Kammhuber line. The Würzburg dish itself was a formidable instrument for its era, a parabolic reflector roughly 3 meters across, operating on a wavelength close to 53 centimeters, capable of resolving a bomber's position to within a few dozen meters out to a working range of around 30 kilometers, precise enough to guide a night fighter's cannon fire onto a target the pilot might not see with his own eyes until the final seconds. That very precision, tuned so narrowly to one wavelength, was also its weakness, though nobody on the German side had yet worked out how an enemy might exploit it. The British had a countermeasure ready. It was called window, strips of aluminium foil, glued to black paper, cut to precisely half the wavelength of the German Würzburg sets so that each strip returned a false echo, indistinguishable from an aircraft. The telecommunications research establishment at Malvern had proven it worked as early as 1942. Air Chief Marshal Arthur Harris held it back for over a year, afraid that using it would hand the Luftwaffe the same weapon against British cities. By July 1943, with Bomber Command's losses mounting and Hamburg selected as the target for a new campaign, Harris judged the risk acceptable. He signed the order for Operation Gomorrah on 27th May. The first raid was set for the night of 24th July. At 22:30 on 24th July, Pathfinder aircraft of No. 35 Squadron begin lifting off from airfields across eastern England, climbing to rendezvous over Cromer before turning east across the North Sea. Behind them, in 3 long streams, come 791 heavy bombers, Lancasters, Halifaxes, Stirlings and Wellingtons, carrying 2,300 tons of high explosive and incendiaries. At 12:24 a.m. the leading Lancaster passes Heligoland, and a crew member begins feeding bundles of window through the flare chute. One bundle of 2,200 strips released roughly every minute on schedule, all the way to the target. Within 4 minutes, the German early warning screens on the coast begin to register the change. Freya operators watch their displays fill with echoes that will not resolve into countable aircraft. At 0:19, air raid controllers in Hamburg issue the first danger warning to hospitals, factories and government offices. 5 minutes later, a second warning follows. By 0:33, the city's sirens are sounding in full. The bomber stream is still out over the water, but German ground stations have already lost the ability to say how many aircraft are coming, or where, with any precision. Inside the Himmelbett boxes, controllers who are trained to read a single clean blip on each Würzburg dish now face screens saturated with thousands of false returns. A Jägerleitoffizier, the fighter direction officer responsible for talking pilots onto their targets, cannot pick the genuine bomber stream out of the clutter. Radio orders to the night fighters grow hesitant, then contradictory, then stop making sense at all. 20 specially equipped blind marker aircraft drop the first target indicators over Hamburg's Altstadt district shortly after 1 o'clock, and for the next 50 minutes the main force bombs an aiming point lit by red and green flares, largely unmolested by the fighters that should have been waiting for them over the Heligoland Bight and again as they crossed the coast. On the ground, the effects diverge sharply depending on who is holding which piece of equipment. Flak batteries around Hamburg's harbour and shipyards, whose 88mm and 105mm guns are normally laid onto target by radar-fed predictors accurate to a few meters, find their fire control radars just as blinded as the fighter direction sets. Crews are ordered onto barrage fire, filling a fixed volume of sky with shells rather than tracking individual aircraft, a method that consumes enormous quantities of ammunition for a fraction of the previous kill rate. Searchlight crews, who depend on radar cueing to find a bomber in darkness before the beam can be walked onto it manually, report their lights sweeping uselessly across empty sky while aircraft pass directly overhead. Luftwaffe night fighter pilots, meanwhile, experience a parallel failure inside their own cockpits. Their onboard Liechtenstein sets, tuned to the same wavelength as the ground radars, fill with the identical false clutter, so that a pilot vectored roughly toward the bomber stream by a controller still cannot close the final few hundred meters by radar alone. Some crews resort to flying visually along the glow of fires already burning below, a tactic that will shortly be formalized as wild sow, freelance night fighting, by eye above the Flak's maximum ceiling. For the bomber crews themselves, the change is felt as an absence. Rear gunners who expect searchlight cones and predicted flak bursts instead report a comparatively quiet run. Aircraft called out of the stream individually far less often than on previous trips to the Ruhr. Navigators aboard the Lancasters and Halifaxes, meanwhile, have their own new instrument to manage: H-2S ground mapping radar fitted to the Pathfinder aircraft, which paints a rough image of the coastline and river below, regardless of cloud, and allows No. 35 Squadron's markers to fall close to the intended aiming point in the Altstadt, without visual reference to the ground. Of the 791 aircraft that took off, 12 failed to return, a loss rate of about 1.5%, the lowest Bomber Command has recorded on a major raid of the war to that point, against a 5-month average, over the Ruhr closer to 4 or 5%. For the citizens of Hamburg sheltering in cellars in the Hammerbrook and Hamm districts, none of this technical drama registers. What they experience is 2,300 tons of bombs falling with far greater weight and concentration than any previous raid on the city. The fire brigades already stretched thin by the scale of the incendiary loads. Civil defense wardens who had drilled residents for years on extinguishing small incendiaries with sand and stirrup pumps now face entire blocks alight simultaneously, a scale of fire no peacetime training had anticipated. If this deep dive into the technical side of the air war interests you, a quick subscribe helps more than you might think and costs nothing. The following days expose how deep the damage runs. On 27th and 28th July, RAF Bomber Command returns to Hamburg with a second and third major raid. Again screened by window, again finding German controllers unable to concentrate their defenses. The night of 27th to 28th July coincides with an unusual spell of hot, dry weather and produces a firestorm in the working-class districts east of the Ulster. Temperatures inside the affected zone estimated to have reached 800 degrees Celsius, hurricane-force winds generated by the fire itself uprooting trees and dragging people into the flames. Over 40,000 civilians are killed that single night, more than the entire death toll of the London Blitz across 8 months. Roughly 1 million residents flee the city in the days that follow, clogging roads and railway lines across northern Germany. German technical officers meanwhile scramble for a countermeasure of their own. Engineers at radar stations up and down the coast experiment frantically with modified receivers, attempting to filter Windows' characteristic drift pattern from genuine aircraft returns, since foil strips fall at a slower, more erratic rate than a powered bomber moving in a straight line. A device known as Wirtslaus is rushed into limited trial use within weeks, exploiting the tiny Doppler difference between falling chaff and a moving aircraft. But it arrives too late to affect the Hamburg raids and never reaches more than a fraction of the radar network before the war's end. Luftwaffe General Josef Kammhuber, whose entire defensive doctrine rests on the precise coupling of ground radar to controlled interception, finds his system defeated by an enemy who has understood its exact wavelength and built a countermeasure 2.5 centimeters at a time. By the close of the 8-day, 7-night campaign, Bomber Command and the USAAF's 8th Air Force together have flown over 3,000 sorties and dropped roughly 9,000 tons of bombs on Hamburg. The Americans bombing by day on 25th and 26th July with B-17 flying fortresses against the port's shipyards and oil processing plants, while the RAF continues its night offensive. The turning point for German air defense arrives not as a single order but as a rapid abandonment of the entire ground-controlled model. Within weeks, Luftwaffe night fighter units begin flying under wild sow tactics, single-engine day fighters such as the Focke-Wulf 190 climbing above the Flak zone and hunting bombers visually by the light of fires and flares, entirely independent of the Himmelbett boxes that had taken 3 years to build. Flak units are issued new instructions to fire unguided barrages over cities under attack rather than relying on predictor radar, accepting a lower kill rate in exchange for putting anything into the sky. Kammhuber himself is removed from his post within months, his elaborate box system judged to have been broken by a countermeasure that cost the British almost nothing to manufacture. a few pfennigs worth of foil and paper per aircraft, against years of German investment in precision radar engineering. The specific claim in Egon's case, that a controller might check and recheck an antenna bearing that was never wrong in the first place, captures something true about the wider defeat. The failure was not in the machinery's calibration, but in its fundamental inability to distinguish signal from manufactured noise, a distinction no amount of technical adjustment could restore. In the weeks after Gomorrah, Hamburg's shipyards and U-boat construction facilities, though not destroyed outright, lose an estimated 2 months of full production, and roughly 580 factories across the city are damaged or destroyed. German war production planners, Albert Speer among them, later acknowledged that 6 or 7 raids on the scale of Hamburg, delivered against different cities in rapid succession, could have forced an earlier collapse of German industrial capacity, a judgment the Allies would not be able to repeat until much later in the war. Window itself becomes standard practice for every major raid thereafter, refined into different lengths for jamming different radar wavelengths as both sides adapt, and the underlying principle that mass-produced radar reflective clutter can defeat expensive precision systems becomes a founding idea of post-war electronic warfare doctrine used long after 1945. The German response is not merely tactical but institutional. Telefunken and the Luftwaffe's own Signals Research Bureau are ordered to prioritize anti-jamming development above almost every other project. And by early 1944, a handful of stations along the coast carry the modified Wurzlaus receivers, alongside new radars operating on entirely different wavelengths, such as the later Freya variants and the centimetric Berlin set, chosen specifically because window cut to the old 53-centimeter band cannot deceive them. None of it arrives quickly enough to matter for Hamburg, and the underlying lesson that an entire defensive doctrine built around a single radar wavelength can be unpicked by an enemy who has simply measured that wavelength correctly is one Kammhuber's successors spend the rest of the war trying to unlearn. Back in the coastal bunker, the night is nearly over. The engineer who checked the antenna angle twice has by now given up adjusting it. His screen still shows scattered false echoes, drifting and fading as the last of the foil settles toward the sea. And somewhere to the south, a red glow is visible on the horizon, where Hamburg burns, 1.5 million people now sheltering, fleeing, or already dead in a city his equipment was built to protect. He makes a final note in the station log, the same note logged by radar posts across the Kammhuber line that night. Contacts unresolvable, cause unknown. It will be days before the cause is fully understood, and longer still before anyone finds a fix. For now, the dish keeps turning, precisely aimed, perfectly calibrated, and still it sees almost nothing true.